Hi everyone, a very happy Janmashtami to everyone. I am Preeti, your host for today, uh, for the session on data warehousing and lakehouses. I am excited to introduce our speaker, Mr. Shaurya. He is a senior data engineer with deep experience across the telecom and energy sector, where he has designed and scaled platforms that power mission critical analytics and real time decision making. He specializes in building modern data architects spanning data warehouse, data lakes, and lakehouse patterns to enable reliable high performance analytics at scale. Over the years, he has led use cases across digital transformation, customer analytics, observability, real time reporting, anomaly detection, and applied NLP, turning raw data into actionable insight for both businesses and engineering teams. What sets him apart is his strong background in search technologies and large scale data storage system, which give him a programmatic edge in areas like indexing strategies, latency optimization, and cost aware scalability. Crucial when deciding between warehouse and lakehouse approaches. At work, he collaborates closely with product, data science, and SRE teams optionalizing everything from streaming in ingestion and CDC pipeline to governance, quality checks, and MLOps handoff. His passion lies in building reliable, future-ready data system with reproducibly and strong SLAs at the core, while smartly adopting innovations like open table formats, metadata-driven or and vector search where they deliver real values. We truly thrilled to have him here with us today to lead this insightful session. Let's give a warm welcome to him. Over to you, Shaurya.
Hi everyone. I hope happy Janmashtami. I hope you all are doing well. Uh, since Preeti has given my introduction, I basically specialize in data warehousing and lakehouse architectures. I am pursuing my MTech in AI and ML right now, and in parallel, I have worked more than 10 years in this area. So today's session basically it encapsulate your data warehousing and data lakehouse. Data warehousing, it has been there for quite some time, and data lakehouse, it is like a new concept in the market and it is growing exponentially. Okay, so in today's session, we will go from the basics of data engineering till lakehouse and try to understand what is going on in this world. And especially, we'll take one data warehouse which is called AWS Redshift. That is one of the most popular product in the market that everyone is using currently, and their customer base is increasing. But when we move to lake house, we'll understand that why we have shifted towards a lake house strategy rather than being a data warehouse system. Okay. So that being said, let's move to our slides. Okay. So the first question about everything is that from wherever we are coming from, the one thing that we need to build upon is data engineering. Okay, it's a completely new subject. It empowers your basically your machine learning, uh, your NLP use cases, which is natural language processing, which you normally see through your large language models through Chat GPT, your Gemini, and especially when now you have the subscriptions for Perplexity, right? So behind everything, it is data engineering. So what is data engineering? So data engineering, it is a practice of designing, building, managing the flow of the data from raw sources to transform, analysis ready data sets. Okay. So this is a very short definition, but this is like the whole and soul of what every data engineer does. Okay. For example, I'll just give you a small anecdote right now. So we have some data sitting over here. Okay. Uh, Let me just take a laser pointer. Okay. So we have some data over here. Let's say this is sitting in one of your systems right now. The next one is in the cloud, and this one is your one of your legacy databases. Okay. So we have something called as integration in between. which pulls and collects all your data. It sends it across the storage and processing. And then you finally have a visualization and a machine learning layer where you do all your dashboarding, your machine learning production environment work, and everything. And your platforms are basically on-prem, cloud, and hybrid cloud. Okay. So a journey of a data engineer comes from point of collection till the point of visualization. And in between, there are many roles that are offered across. And the 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 entry level role, I would say, that is a data engineer. Uh, I would say an associate data engineer. And from that, it goes up to a solutions architect or an enterprise architect. Okay, and then there are various responsibilities in between to to basically to a person who's going through. Okay, so we will come back to this architecture again and again throughout this session, and then we'll break it down to understand more about it. So moving on. Okay, so basically now we saw this big architecture over here, but for a data engineer, what is a data for us? Okay, so there basically for us, data is divided into three parts. The first one is your structured data, which is basically is a data that has a standardized format for efficient access by software and human alike. Like you use Excel every day, that is a structured data where the data is in a tabular format. Like it is also human readable, or you have CSV files. Those are basically your comma separated files. If you have paid your income tax this year, you might have known that you can export your income tax in CSV also, or some data from government websites in CSV. So basically, the first header of that particular file is your basically column name, and then the data follows. Then you have a semi-structured data that sits between your structured data and unstructured data. Okay, and it has some basically organized structure in it, but it is not strictly tabular. So let's say we have JSON. So JSON is a file format which is quite popular these days, and you might have used it. And then there are some system logs, and then there is a time series data. Okay, this basically defines your time series data. So if you are a very popular SIP, you do systematic investment plans, you are basically using Grow or any application these days, you might have seen your stocks are coming in a time series format. So you have the time of the day at the bottom and your value of your stocks coming on the left hand side. Okay, those kind of data are called time series data. Logs are basically your system generated data. So these are basically designed by your developers. Whenever you have some kind of an issue, these logs are generated. I'll tell you why this is very important to capture logs these days. And there is a complete field behind it, which people are doing. Okay. And JSON are basically semi-structured logs, which are basically, those are basically a key value pair. So key means basically, uh, let me see if I can draw something here. Okay. So something called as key value pair. So basically you have a key. Let's say the key is name and your value can be some name over here. Okay. And JSON is basically a bunch of key value pairs nested inside each other so that they can basically have a lot of data inside it. Okay. And these are very good for transmitting data across your APIs. Okay, and we use it a lot. Then comes your structured data. Okay, then comes your unstructured data. Sorry. So unstructured data is basically your raw text, maybe your PDFs, your videos, and the audio files that you are generating. These are data sets. Basically, they do not follow any format. Okay, your videos, they have, maybe there are it is an MP4 format. Your audio can be an MP3 MP4 format again. Your text can be TXT file, something. But nowadays, if you put your text file in an LLM system, what it does is basically it will do an OCR on it, optical character recognition. If it is a PDF, or directly it will analyze your text and give you the whatever. Then you can ask all your question answers over there, and it will help you across. But video analytics, it comes under a lot of machine learning is required. Okay, and audio is also machine learning. Okay, so in today's session, I think we'll focus on your CSVs, your tabular format, your structured data basically, and some level of semi-structured data as well. Okay, so let me just see what is going on in the chat. If JSON or certified is not coming under unstructured. JSON is basically semi-structured. Mostly we keep tabular format as structured data, but your definition can change. Okay, and for the job side, maybe I'll give you some tips. Okay. Okay, so moving on. Okay, so let's go back to the diagram first. You see these are dotted lines over here. They're moving from one point to the other. These are called basically pipelines. Pipelines are your, how would I say? These are data processing engines. You can say that there are a lot of jargons in data engineering. My job is basically to remove everything and give you the real deal that's there. Okay, but there are some jargons which even I can't leave basically change, and those are like data pipelines. Okay, pipelines is a workflow that ingests, move, transforms raw data from source to destination, where it can be used for analytics, ML, and business needs. Okay, so till now you might have seen our diagrams are more based on icons, like over here. Okay, so we have shifted to something like this right now. So whenever you are working in your company, most of your diagrams will look like this. Okay, I'm just giving you a perspective with respect to your job. Okay, so let's see what are the components of a data pipeline. So data pipeline has a source. Okay, your sources can be your databases, your APIs, your files, your IoT and edge devices. Okay, and from there you have an ingestion system in between. Okay, those basically read all these things and they bring it to a standard staging area, you can say, or in their memory. Okay, and then they do some level of batch processing. So what happens in batch processing? See, I'll tell you something. If you are doing your work, if you have given an assignment, you do it in one shot. Okay, finish it off, put it on other side, and then you don't touch it your next assignment for like next half an hour or so. That is called a batch processing. But when it comes to streaming, you are basically continuously processing your assignment. Like you are going by question one, question two, question three. One assignment is finished, you bring the next one. So that's how is basically your streaming works. It is a continuous process. It doesn't wait in between. Okay. And the third thing is, which is coming these days, it is called CDC. That is your change data capture. What happens in change data capture is, uh, now suppose that you have a file. Okay, your file is sitting over here somewhere in your cloud. Let's say it is sitting in the cloud, and you basically generate a log at right now maybe it is 215 or something. Okay, and at 220 you generate another log. Okay, in the same file. So now what happens is if I have like 100,000 lines in those files, okay, and that is still 215. But when it comes to 220, it is 100,001. Okay. So normally any integration tool over here will read those 101,000 lines to basically understand that is your last line that has been added. But what happens in change data capture is it will only basically capture the last part which has been added. Okay, but change data capture facility is not available everywhere. Certain tools they provide it. Certain in certain areas you have to write your own script to get that change data. Okay, so this is your source. This is ingestion. Then comes your processing and ETL. Okay, this is the area where you do a lot of coding. Normally, why I'm saying why you do a lot of coding over transformation and processing, because normally if you see on any website, your ingestion plugins are already there. Okay, those are already made for you. You just need to put some settings over there and things will work accordingly. Maybe your settings can be like which table you want to scan, which file location you want to scan, then at what frequency you want to scan it, and what kind of a data you are expecting. Okay. So what happens in processing area is that transformation area, there are two ways to transform a data. Normally it is ETL, that is extract, load, and transform. Extract, transform, and load, and ELT, extract, load, and transform. Okay. Okay. So processing, you can like operation wise, it is written over here. It is cleansing, aggregation, and enriching. Cleansing means you remove all your white spaces, any special characters that are coming in. And aggregation, maybe you are aggregating your data. Let's say you are aggregating your data for last 1 hour, how much items I have sold. Okay. You're not going to do this aggregation over here anywhere. You are just doing your aggregation at the processing level. Okay. Because you don't require, like, if there are 100 or 1,000 records coming in for 1 hour, you don't want to put everything on your lake house. What you will do is you will just do the aggregation over here and put it over here, because that's the data that you need. You don't need everything which is coming to you. Okay. And enriching means, basically, suppose that you have a name that is, my name is there, Sohar Joshi is coming up. You want to know what is my address. So you will have another system connected to your pipeline where the table sits with the primary key as my name, and you will basically search over there and bring my address and phone number, pin code, everything across, enrich that data, store it in a lake house or a warehouse. Okay. Now, comes the storage. So storage can be your data lake, data warehouse, and data lake house. I think we have people from various backgrounds. Some are already experienced. Some maybe understanding this for the first time, and let's say some are only coming here for hobby and something like that. Okay, so I'll give you the difference between data lake house, data warehouse, and data lakes. Okay, normally, our journey basically it starts at data lake. Okay, data lake you can throw as amount. You don't need to process anything. You put all your data over there. There you don't need to do this processing thing. Just keep putting all your data. It's a very cost effective and efficient storage, and you keep adding as much data as you want. Okay, there is no. I think your cost per GB will be quite less compared to a warehouse or a lake house architecture. Okay, maybe let's say compare it with the warehouse. Now, what happens in a warehouse architecture? Warehouse, what happens is your cost for every query that you will ask your system, every SQL query, everything that you are trying to store over there, it will have some kind of a cost in it. Okay. Maybe your retention cost is there, or maybe your querying cost is there. Cost also depends upon the memory that you are consuming, and there are certain factors in it. Let's not go like complicate things, but let's understand. In data lake, you can put a lot of data. In data warehouse, you can only put data that is required. Okay. Then moving on, so you might have understood that I have explained to you ETL, but I have not explained to you ELT. Okay. When I said lake house, ELT plays a role over there. Data lake house, data lake, sorry. It is ELT means extract, load, and transform. So you ingest the data, you don't do any level of processing. You basically store your data on the lake house and start processing it in the warehouse. Okay. So ELT is our go-through method these days, and people are not very keen about ETL because, first of all, if you start doing your transformations at this level, you will have a bottleneck, a strong bottleneck, I would say. If your ingestion rate is like 100,000 a minute or something like that, which is typical in case of a production environment. Like you will have 100,000 messages coming in. Maybe you're getting 100,000 logs every minute. So transforming it on the fly. Sometimes if you have a lightweight processing, it is fine. But if you have a heavy load in processing, don't do it over here because that will be a bottleneck for your system. Do it in the warehouse. Do it with Apache Spark in the data lake. Again, store it and it will help you out. Okay. And finally, basically, you have a BI consumption layer on the top, and you basically generate your queries on the consumption side. It gets processed on your warehouse. It gets processed here also sometimes, and that's fine. Okay. And for people who are like, who think that this is a very hard and fast, that this happens in this, that happens in this, it's nothing like that. Okay. One thing I also want to tell you that before moving to storage, sorry, orchestration, I want to tell you something regarding data engineering. It is not development work, okay? Like a developer, you have to like think more in terms of your cost, scaling, ingestion rate, and how multiple systems work together. Writing a code in data engineering is not as required because there are tools which are already available for plug and play, and the industry is moving in that direction. But what you need to focus on is to work on large amount of data. Okay, I'm not discouraging the development work, but my idea over here is to understand the system at scale, because writing a very efficient query, now you also understand that nowadays I think you, with the help of a GPT tool, you can basically write as good query as an 80% of the top engineers worldwide. Okay, you just need to know the right prompt, or you just need to iterate it several times, and you will get the most efficient query out of it. So development job is more or less a supportive right now, because we don't develop new tools in this. Okay, and you have to look it on a larger scale. Moving on, now what happens with orchestration? Why orchestration? There are a lot of things in orchestration. Okay, this is a very important thing, right? Sourcing, ingestion, processing, everything you can do. Orchestration, this is the life of any tool. Okay, you do you do a very simple job over here. Nothing special out of this world. You just do scheduling, workflow management, and automation. Okay, uh, in a typical project, you have like several hundred pipelines, maybe running up to thousands of pipelines. If you check on Uber blog, they have like 15,000 something like pipelines running in parallel. How do you manage so many things? You do orchestration. There are teams which do orchestration. These pipelines are scheduled to run every day in the morning, or maybe like every half an hour to aggregate data, or at the end of the day to give you some results. Okay. On top of that, there is something called as monitoring, and this is the if you see in today's job, you will have Elasticsearch and all those tools, Grafana, Prometheus. They are being required by every data engineer. I would say that you should learn them, because tracking the quality of your data and basically checking the errors which are coming in your pipeline, there has to be a tool in between which is monitoring. Okay, and the performance monitoring of your pipeline. Suppose that out of 100,000 pipelines, uh, let's say several of your critical pipelines are getting bottlenecked. How would you know? So monitoring plays a very important role. Whenever you are building code for your pipelines, there are a lot of monitorings which are required. Some are done through standard libraries. Some are done through Spring Boot. They have their own actuators also. Prometheus is good for doing that, but some tools already they have things built in it. Okay, and consumption I've already spoken about. You might have used Power BI, Qlik, and Tableau. All these things sit in the consumption side. Okay. Let's see. I saw that there are a few messages coming in this. Okay. Uh, with costing, we'll see, because Lakehouse is not just a storage system. It has multiple things attached to it. Okay. Uh, Jacob, I'll see if I can give you some Lakehouse use case, but I'll give you a use case which I think I'll give you a standard use case, or maybe something that you can think about. Okay. Moving ahead. Next is, since we are in data pipelines, we have some data pipelines patterns in this. Okay. So you have your batch processing, okay, which I have already told you. Like you do one assignment, break for half an hour, you do the next assignment. Streaming, that is your real-time pipelines. You are basically processing your data continuously. Your pipeline never sits idle, or it is basically, if it is sitting idle, some of its code will always be scanning that particular location or the particular database to understand if there is a change or not. Okay. Lambda architectures. These architectures are very common. Maybe if you are working right now, if you are using an app right now, somewhere down their system in the back end, they might be using a Lambda architecture which combines a real time and a batch processing layer. Basically, your real time data is processed with one pipeline, batch is processed with one pipeline. There is one more architecture I didn't add because that is called a Kappa architecture. It is a continuous streaming architecture. Everything works on a stream. You have your Apache Beam over there. On Apache Beam, you can basically write code, and I'll tell you about Beam down the line. But what it does exactly is it's a streaming engine, and basically it uses micro batching from Spark to to keep your data processed in a very short interval. Okay, but Kappa architecture, na, it is very expensive. I'll tell you, if you read blogs about it, now you cannot keep your pipeline running 24/7. Your cloud compute cost will go beyond your control, and certain projects uh, down the line, if I'll also tell you, there is a change in trend also, right? When I went over there, now, if you see platforms over here, I said hybrid cloud at last. Now what is happening is there was a time when people used to come to cloud, okay, on-prem to cloud. They put your data on the cloud, and that time they were building pipelines on the cloud. Down the line, after building everything going productionalized, they understood that there is quite a cost involved on the cloud environment, and then they started doing hybrid architecture. Okay, the basic thing about cloud is you can put as much data as you want on the cloud, but once you start retrieving it, there is an egress cost to it. And at that point, people started understanding, let us do an hybrid cloud architecture. What happens in hybrid cloud is your integration, na, your integration is here only. It is on the on-prem environment. On-prem means you have your own servers in your office. Your data is getting generated in your office servers. Your integration is being done. Your processing is all being done over here. And some important data, sometimes even your some level of storage is also here. And from that storage, you add one more integrator and put it on the cloud. But then what happens is the amount of data that is going on your cloud remains less, so that the costing can be controlled. Okay, because whenever you have like X petabytes amount of data sitting there in the cloud, you try to do a level of processing on it, you will definitely incur extra cost. So then came your hybrid cloud architecture. Okay, so that was just something that I wanted to add on. ETL, I have already explained: extract, transform, and load. This is a data transform before loading into the storage. Okay, and ELT, your extract, load, and transfer. This is now very popular. Change data capture is also popular. This happens in your lakehouse architecture a lot these days, because they just want to capture that data that is coming in and put it on the storage. And then comes your data lakehouse pattern, which is unified storage and analytics combining data lake and warehouse principles. Okay, so lakehouse basically it unifies your best of data lake and best of warehouse, and that we'll see when in some time. Okay, now on the right side there is a company called as Informatica. So Informatica is a basically it relates to data processing and all that, and they have created this diagram to basically clearly represent what happens. You have your on-premises database, you have your edge use cases, you have your SaaS softwares, you have your cloud. So on premises, I told you bare metal servers you have, you will run virtual machines on it, and your applications are running in your servers, which are sitting in your own data centers or in your offices somewhere. And you have some kind of a integration system, which is basically sending your data to the cloud, or it is processing it somewhere. Edge cases means you have your IoT device, you wear your fitness trackers these days. Those are the best example of your IoT device. Okay. Whenever you click on that, we want to support the analytics and we want to make your product better with analytics, you are sending your analytics over there. The good part is it is anonymous. I think more or less it doesn't send like which users held data it is, but sometimes they receive the data and they are running machine learning to improve their software package. Maybe the exercise that you want to do, maybe you want to do some running, you want to have your better recordings and more accurate recordings, or some kind of a recommendation that's done through the data that is getting generated on the IoT devices. Then you have your SaaS products from your Salesforce, then your HR apps and everything. And those are also getting integrated, and they are getting integrated through APIs. Edge devices, they get integrated to stream ingestion, means they are using stream pipelines. On premises, sometimes they are using batch, sometimes they are using your stream also. And API integration basically is your application, what do you call it? It's an interface basically, REST APIs these days. Those are very popular in and basically uh, transferring data between the user and your mobile phones and everything. Okay. And then comes your cloud. If you have a multi-cloud environment, like after hybrid cloud, there is also multi-cloud. But multi-cloud, it requires a smart team, because certain products you are using from somewhere, certain products you are using from the other vendor, and you want to integrate at a whole platform level. That requires some good level of data engineering to. What happens is, see, every cloud vendor is giving you the same product, and if you go to a different cloud vendor and you try something else, your costing may be going up. So instead of using a different cloud vendor, you use the same cloud vendor and break a deal with them, and you get more, you become more cost effective. But sometimes you don't get that use case and you move to a different vendor. The good thing I'll tell you is, one example you can think of is Databricks. Even if your systems are running on the cloud, many people, they try to get the Databricks solutions working as a separate system, so that because their team is familiar with the Spark. Although you have Dataproc, you have EMR on AWS and Azure, I'm not sure. I think Azure also has a partnership with Data Lake, Databricks, so they might be having their solution deployed over there. So that's how it works. Like Dataproc in AWS, I think if you use Dataproc over there, if you use it on AWS, sorry, Dataproc is on GCP. If you use EMR, there might be a difference. So those who are already coming from GCP and migrating to AWS, they might want to retain the Dataproc over there and use Dataproc in that system and keep all your services over here. So that can be done through networking. And then you have your data lakes, then you have your use cases over here. So let's move on. Okay, so what are different kind of transformations? So you have your ETL. So when you have an ETL transformation, the advantage of an ETL transformation is it cleans your data before storage, that we have already seen, optimized storage for use. But the disadvantage, why I've kept this, I want to clearly make it to you that this is quite important actually. If you are a seasoned data engineer, you will understand that where to use ETL and where to use ELT, and zero copy is something else. I'll come to that. And disadvantage is it becomes slower. That's what I told you. Your bottleneck, most of your times when you are trying to find why your system is getting slow, even if you are having a good I would say an architecture which you have already sized, right sized for your requirement, but it is still getting slow. Sometimes your ETL is your problem. Okay. And slower extra processing before load, need external ETL tools. And your common use cases are traditional BN reporting. It used to happen, it happens in many companies still. Okay. We also use ETL somewhere, but ELT are go-to choice, because in a mobile data architecture on an IoT devices and energy, I think ELT is a better choice than ETL. Then you have faster ingestions, leverage warehouse computing power, flexible for reprocessing. Okay. So faster ingestion, load raw data first, leverage warehouse compute power, flexible for reprocessing. This what you understand, reprocessing. ETL, you will, what whenever your data is processed, you will only send the processed data into your storage. Here you can keep some data for your future analytics or machine learning need without throwing it away. Okay, so this is one more advantage of reprocessing it. Requires powerful modern warehouse of raw and transform data may increase the cost. That's one area, but yeah, I think odds are on your side. If you are, even if you are paying the extra cost, you are getting a lot of benefits out of it. So cloud warehouses are like Redshift, BigQuery, and Snowflake. Zero copy ETL, no redundant copies, saves storage and time efficient for large scale. So basically, it copies your data in memory and basically it processes it. Limited to platform that supports it. Okay, Redshift supports it. May lock you in the vendor. If you are using zero copy ETL a lot, I have not seen any use cases till now of zero copy ETL. Maybe I think it is a new in the market, and we will see it down the line how it performs. But we'll stick to ELT for now. But this is also a good thing. But I haven't used zero copy till now. Uh, they say that they use it in machine learning and all that when they need to do some experimenting of A and B. You know, when you are doing machine learning, there are one algorithm might not help you out. It might be underfitting or overfitting your requirement. So you have to do a lot of experimentation. That is all machine learning and data scientist is all about. Okay, data scientist is not about basically giving you an output saying that 85% your customers will retain. No, no, the data scientist is about basically telling you this is your problem, this is the data, I've understood the data, and these are certain level of algorithms that you need to use to at least have a 90 to 95% accuracy. You go beyond 95%, it might overfit means your data set basically you have a training data set where you train your machine learning algorithm, it will perform exceptionally well, but when it comes to real world tasks it will fail. That's called overfitting. Okay, and to whenever there is an overfit, you need to go back, copy that data in your system, try to process your machine learning algorithms again and again. There you need a system in between where you will do all these processing, and then zero copy helps you to reduce that copying cost of tables, and it helps you basically see any data in your company without copying it, but you can process it. So whenever you have your experimentation on machine learning, zero copy helps a lot. That's the only use case I've seen it across. Advanced analytics, lakehouse style platform. And lakehouse is not just one way of doing things, okay? Warehouses are because they have reached their peak level of research where they see like this is the way it can be done very efficiently. Lakehouse, you will have multiple architectures, okay? Your front running teams like from Microsoft Fabric, Azure Fabric, your Databricks. Databricks is the team who brought that lakehouse concept. They have a research paper in 2021. You, I have a link for that research paper. Go and have a look at that. I think that will help you out in understanding what exactly the lakehouse is. Okay, and there are multiple architectures for it. Nothing. It only depends upon how is your problem being given to you. But the standard level like storage and all that, they remain the same. But there are good, it's good now, you can play around and you can have your own query engine, you can have your own analytics engine on top. You don't need to sit for a vendor to give you a solution. You can switch if you want. That's a very good advantage. So what are data warehouses? Okay, so basically data warehouses, those are a data warehouse is a central system that consolidates data from different sources, organizes it, makes it easy to analyze, and for business needs, yada yada, multiple things in it. Okay. Normally I don't like presentations because I have to read a lot and I don't actually it doesn't help me a lot because this is a different kind of a field. But since it is for different, if it's for a wider audience, I have a lot of things in it right now. So key features are you can read, stores integrated data from diverse system, databases, application logs, optimize for read-heavy workloads, business intelligence, dashboards, and analytics, support historical trends, analysis, and decision making, uses schema-based storage. Okay, this is important. This is important. Okay, schema-based storage. you might have seen that if you सबसे simple I think the simplest data system that you can use it na, if you really want to practice SQL, is your SQLite. You download your Linux, you will have SQLite in it. Most of your commands will work. It is not very good with joins, which I have understood, but yeah, for a beginner to learn SQL, SQLite is the best for you. Okay, so whenever you make a table over there, you have a schema, and with that schema, basically you have to follow that schema. If you don't follow that schema, your system will break. I'll come to NoSQL also if you want. Basically, I work on the NoSQL databases a lot more than your standard SQL databases. There is a message over here. I am not able to view any chats. I think this is Preeti can help you out. Okay. Okay. So, so instead of going into a lot about the architecture of data warehouses, I have kept it into 4 layers. There is a storage which is columnar based storage. Okay. So whenever you look at your tabular data, it is in a row and column format. Okay. Not very efficient when you want to do an analytics job. You know why? Because if I have products, let's say I have 1 million products, okay, and the serial number of the product starts from 1 till 1 million, okay, and I want to see that how many products are sold in last 1 month, okay. 1 million product is just a hypothetical number. I could have put, let's say it is 1000, okay. Once say 1000 tak we have like our name of our basically serial number, and we want to see how many of them have been sold in 1 month. So if you have a tabular format like a row or a column, okay. So if you have a tabular format like this, okay, this might, I think this is an easier way to understand. You might be getting in your head like, if I can do this more, that will be helpful. Okay. So let's say if you have your sales over here, okay, you have your serial number over here, okay, and you have your column A, your column B, and let's say these are just remarks. So if I, and this goes up to, let's say 1000 SKU, Shark Tank language, SKU, okay. So uh, let's say we need to see for 1 month. Great. You read it. You will read all the columns. You'll read column A, column B, your sales column. And what happens is 1000 multiplied by 3 is equivalent to your 3000 read items in your memory. Not efficient at all. Okay. But what happens in columnar storage? They are stored as a particular column. Okay. So when you are doing a columnar storage, they will only store this as a complete column. And if you want to know like how many products have been sold for last 1 month, you will only need to do 1000 values in your memory. Almost 3x better storage capability. So that is how a basic, these are just the basics of the columnar storage. But if you want to do more, like you want to see, like I want to see for 1 month between ID 300 and 600, how many products have been sold for 1 month, that's a different story. It will also come through columnar storage only, okay? But that's a bit complex. But this is the basic concept of a columnar storage, okay? Highly efficient. And one more thing, okay? When you are a data engineer, na, if somebody asks you what is the setting of a particular thing, I would ask you a question, what is your compression ratio? Okay. Compression ratio is the most important thing in your cloud. This is going to save you a lot of cost. Okay. Suppose that you have a 10 KB file. Okay. And if I'm thinking right about the compression. If I do a 1:10, I think this should come out to be 1 KB. Correct me if I'm wrong, but this is how compression works. And in columnar storage, you get a very good compression. You know why it gives you such a good compression ratio? Because your data type remains the same. Suppose that this data type is numerics, and if you are trying to compress this, you have the same data type across. But let's say if you want to compress a row, you have multiple data types. You have your string over here, numerics over here, something else over here, maybe a float. So compressing this will not give you that level of efficiency. But when you have a columnar storage, it gives you a good compression ratio. And when you are basically having like 10 petabytes of data, you really need that compression ratio to help you out. Okay. Okay, I'll just clear this annotation. So far, so good. Can you just in the chat? Can you interact more? I want to see, like, I'm not getting any feedbacks over there, so I'm just moving ahead. I don't think so. Redshift is not free. You have to pay. Postgre is free. Redshift is based on Postgre. Okay. Thank you for the appreciation. Yes. Okay. Moving on. Okay. On the right side, let us discuss this thing. This is quite important. Okay. Anywhere in the interview, now, if somebody asks you, they should ask this: internal architecture when you have it in your data warehouse on prem, and when you have it on the cloud. So whenever everybody says, "No, this is cloud, I am doing this and that," I will always say, you don't go for the jargons. It only disturbs your mind. Cloud does two things. Why cloud is made? You know, to basically give you that level of elasticity. Okay. If anyone has worked on HDFS, right? Hadoop systems, they must have understood what I'm saying. Scaling a Hadoop system is very difficult. It only scales, I think, vertically. If you want to do a horizontal scaling, you need a new server, I suppose. I have not worked on HDFS that well, but I know this is one of the issues. I work mostly on the NoSQL databases. We have a sharding system over there. It scales quite well. Okay, so scalability. क्या होता है scalability? I'll tell you. So when you are sitting on your on-prem system, now if this is a big server, we don't need this big server. Okay, so let's use this scalability. This is your on-prem system. I'll make two boxes over here. Okay, what is inside this? Inside this, there is a CPU, there is memory, there is storage. Okay, in cloud, this is separated. Okay, you have your storage on one side, CPU and memory on the other side. How they do it? They do it through virtualization. Okay, virtualization means if you have, let's say you have an AMD CPU. Mostly these are used until they use AMD Epic, if I'm not wrong. This is also used a lot for gaming also these days. AMD Epic, they say it has 128 cores, and you can put up to 1 TB or 1.5 TB of RAM. Okay, when you have a virtualization on top of this, it will break you into, let's say, 8 cores, virtual cores. These are not physical cores. I'll tell you why. I'll come to that. And this each of your virtual machines will have 8 GB of RAM. Okay, this virtualization is also done on the on-prem also, but this is something different. Okay, when I say virtual CPU, that is just for your knowledge. Any CPU, it has two threads. Okay. When they say virtual CPU, one thread is one VC core. Okay. And when I say two threads, you have two VC cores. So whenever you are selecting your system on the cloud, you should look at, if you are thinking that it is giving you two cores, no, it is just giving you one cores with two virtual CPUs. Okay. So you should understand this first. Now, what happens on the cloud environment is, what happens on the cloud environment is, your compute, you can take as much as you want. Your storage, you can take as much as you want. But when it comes to on-prem, your bare metal servers sitting in your data center, those are limited. Okay, these devices are limited. So if you want to increase it, you have to add +1 to it. again plus one more device, one more device. But cloud, it has a lot of resource with it, so you can expand as much as you want. So this is the clear advantage that you get when you're shifting to a modern cloud data lake warehouse. Okay, so see, your storage layer is different. Okay, your compute layer is different, and your service layer is different. Here, your storage area basically, the data warehouse running on your Hadoop system, it will have its own CPU, RAM, storage on a single server. And I'm telling you, when this happens, back in 2011, 12, people used to, like, if you have talked to your brothers and all that who were working with the data warehouses, they will say that we have a server farm sitting with us. You know, when they used to hire a server farm now, they used to hire all these three things. They did not have the ability to have different size of storage, different size of compute. So you can basically get 12 cores, 24 GB RAM, and with that you can get 8 TB. Today, if you want to get an 8 TB on this, you need to change a motherboard, which means you have to completely change your server. Okay, this is a clear advantage of your of having an internal basically your on-prem systems, your modern cloud systems. Okay. Okay, so this is some knowledge you can use down the line when you are having going through your interview. You can explain to them. Okay. Okay, let's go ahead and okay. You have your staging area, the data integration area, your central data lake, data marts. Okay. I have spoken about this. I've spoken about this. I'll speak about this, this, encryption. Okay. Column storage, I've already told you. I'll tell you object storage here only. Okay. Caching, I'll tell you. Okay. Scaling, I think right now you don't require it. I'll tell you about your metadata. What is a catalog? What is governance? Okay. This part I've already spoken about. So let's say what is your staging area? Okay. When you are bringing your raw data with E, L, and T, you put it on your T is over here, right? Your L, sorry. Your loading happens in your staging area. Okay. When you are in the staging area, you put a lot of data over there under a transformation, and what happens after that is it goes to your transformation area. Basically, it's a transformation table. You have a staging table, then you have your transformation table, your staging table, then you have your transformation table, then you go ahead. Okay. So in the staging area, you keep putting as much as you want. You put like 100,000 millions of records or billions of records over here. They will be sitting here without any transformation. But when they go into that transformation table, processing starts. In between, also there is a processing. After this, also a processing. It depends how you want to architect your pipelines and processing. Okay. You'll have your cleansing, deduplication, aggregation. Deduplication is very important. You don't keep your duplicate data over there. Whenever you're doing counts, your duplicate data will basically kill it. Okay. Now data marts. Okay, so you might have heard about data warehouse, data lake house. What are data marts? These are subject specific. So if I'm working on an e-commerce company, I want to see my financial data. So financial data will have its own warehouse, okay, where it keeps all your transactions, everything over there. Then it can be your customer support can have its own database where you have your CRMs sitting. Okay. Then maybe another system. So data marts are more specific. They are not like your data warehouse, not like your data lakes, not like a lake house. Very specific, very small. But the best thing about them is you get all your data curated over here and you process it. There is one more thing which is now replacing, or would say it is going parallel to it. It is called data mesh. Okay. Nothing advanced in it. Only what happens is there is one department over here, one department. This is an e-commerce department. This is your finance department. E-commerce wants to know what is your data on the finance department. Finance wants to know what is there on the e-commerce. They have an API sitting in between. They maintain their own data over here. They maintain their own data over here. They talk to each other. They send the API call. Why API? Because they want to have some governance over it. Governance basically means the amount of control you want to give to somebody about your data. There are certain columns like pricing, right? So finance department doesn't want the e-commerce department to know the pricing, and this happens in a lot of construction companies. Your procurement department doesn't want the everyone to know at what cost they have procured the items. Okay, so they will keep that particular column hidden from everyone. Maybe your salaries, your per day salaries which are getting charged from your client. Your company doesn't want you to know. That happens. So what will happen is they won't give it to the HR. They will hide that column. Nothing will come over there. Everything is secure. Nobody knows. Okay. So so that is what APIs are basically being used for. And data mesh is good, but this is again a new concept. These are like every data set in this is like a product, and they maintain with their own team. But I believe that this will have a lot of cost because not every team knows how to keep a data engineering team. There is a cost overhead with a lot of people over there. Okay, so having a data lakehouse is much better. Okay, so I've spoken about data marts. Now the OLAP systems. So whenever you are working on any analytics platform, then you have a twin brother called as transactional platforms, born on different timings. Okay, they serve a different purpose. Analytics platform, they have columnar storage. They are optimized to do analytics job, and they keep certain level of data. Transactional databases, when you are doing a transaction on UPI, you are doing a transaction like NEFT, you are depositing money to your bank. Those, I can say, those are some transaction system. Those are ACID compliant. Every database has to be ACID compliant, I would say, because what happens in our ACID compliance is, these data sets, they are very what do you call it, very reliable. I would give an example. Tomorrow you are adding some money to your account or sending some money. Suddenly your internet fails. Okay. And you have pressed the button of send. You will be confused what is the status of my process. But with the asset compliant database, everything is tracked from everything, I would say. And if something fails, it will roll back to your to the initial state. You have seen your refunds coming over there. If the transaction fails, it is the part of the asset property of any database. It will roll back. It will revert your money, something like that. Yeah, it requires more scripts on it, but something like that happens. Okay. Then comes your encryption, very important. Whenever you're keeping your data, keep it encrypted. Nobody knows which backdoor is open, how you can you get your data exposed. Keep it encrypted. There are standards for encryption. Those are called and every system, cloud system has managed keys. Okay, MKS system, managed key system, they call it. So your data is getting encrypted with a key, and sometimes that key is in the cloud or it is provided by the customer. Either it is there in the cloud, given by the cloud, or it is given by your customer. Okay. So this is, and 100% you have to encrypt. You can't leave your encryption. Nobody, even if somebody says you are sitting behind a VPN, okay, or a VPS, they say that we don't want to encrypt it. No, go for encryption. There is always a 0 day in every product. If it gets exploited, your data will get exploited. So always encrypt it as a safe thing. Encryption doesn't mean it can't be broken, but yeah, it gives you a certain level of security to your at least you are basically following the local laws or government laws. Okay. Then comes your object storage. Okay, this is something which is important. Object storage, if you look at your S3, most popular simple storage service, GCS, Azure storage service number. I think they have now given 2 with it. Those are the version 2. Those are they are all object storage. Okay, your data is stored as object blocks inside your storage. I have time? No, I think our time is running. I can explain more about object storage, but this is what you basically, they are stored as objects. Okay. Caching, this is one thing data engineers should know. Whenever you are running a query, okay, on a data warehouse, you get a result back, right? Okay, those are stored in your memory. That means RAM. You cache all your storage. What will happen is, if you want to do the same query 100 times, you don't do it and run the system again and again. From the RAM, the system will give you the response very fast without doing any processing. Caching is the most important thing. Now what happens is, these days you get 1 TB, 10 TB of your distributed processing RAM. So you can basically bring all your data set on the RAM and it becomes quite efficient. Why? Suppose that this is your CPU, this is your hard drive, this is your SSD, okay, and this is your RAM. Hard drive is the slowest, I would say, okay. SSD is quite fast, RAM is even faster, okay. So RAM is the most fastest available thing in your system. And then there are L1, L2, L3 caches, but those you don't need to know. Only just understand RAM is the most important, fastest thing that is available to you. So whenever you want to do processing, use RAM. Don't use try SSD, but SSD VMs will be very expensive. Don't go for that. Take an hard drive, put everything on your RAM, process it. Nicely done, without any extra cost. Okay. And metadata is the living soul of any lake house. What happens in metadata is basically everything that you are doing today, it is having some kind of a metadata. uh, Suppose that you have a table of cars. You will put, this is the car type A, okay. You can have another field in metadata, maybe ranging of cost, and several hundred fields. Metadata basically, it's not a data that's going to give you a value, but it stores a data about your original data set, and this makes your searching very faster. Okay, if you just see one column saying that this is car A, it's not going to help you out that much. Okay, but if you have a metadata attached to a table, it will make your search very fast. So metadatas are the living soul of every lake house. And then comes your catalogs are basically, with the help of metadata, they are maintaining your tables. Okay, whatever columnar storage you have. Basically what happens now, when you have like in one project, a friend of mine had 24,000 tables. How will you know in 24,000 tables what you can, where do you want to search? You will go to the catalog has all the metadata of every table. And if you search in the catalog, you will know that this particular table is where I need to work on. Okay. And governance, basically it controls what you are doing. Okay. You might have heard about IAM. Okay, so there are basically role-based access control. Then there are other things also. So these are access control. They can give you a control till a field or till a value. If you don't want a person to know a value, like I told for the HR, that they can't know that at what rate you have been hired by your client. So they will not know because you have put an IAM policy in between. Okay, so let me just clear this up. I don't know that there is a quick way to do this. Is there? No. Think clear all the drops. Yeah. Okay. So moving on. Okay, so traditional data was data warehouses and modern data house architecture. They are tightly coupled. I told you, right? In the same VM, you have your RAM, storage, and everything in one place. These things are decoupled. Independent storage and compute. Scalability. They are very limited. HDFS doesn't scale that well. So if you have used Dataproc on GCS, GCP, they will give you their GCS storage instead of HDFS storage because that scales well. Okay. Then comes your, these are elastic, scalable deployment. These are on premises, setup heavy, and yes, they are quite setup heavy. Something breaks, your entire system will go down. These are self-managed, but self-managed comes with a lot of cost. Okay. Cost models, fixed cost, you give for hardware, you give for license, you have a pay as you go. Tomorrow if you don't want maybe certain level of data warehouse, you stop using that service, they will not charge you. But if you have paid the license fee for 3 years, you will be stuck with it. Okay. Separate compute, storage billing. So your compute billing comes different, storage billing comes different. You can have a 12 core processor with 10 maybe 5 TB of space. Here you have to buy 24 core processor to have 5 TB because you don't have a motherboard with you which can do this. Data types mostly structured. You can have structured, semi-structured, sometimes unstructured data. Okay. Performance optimized for batch ETL and reporting, optimized for concurrent queries and mixed workloads. Okay. ETL you want to do your reporting, you go with this. I think these systems are good. Example: Teradata, Oracle, Exadata, IBM, Netiza. I think these were the examples I got, but there can be many more examples. You have Snowflake, Redshift, BigQuery, Synapse. Okay, moving on with the Redshift. Okay, there is a message. Okay, IAM concept. Okay, IAM is basically an access management concept where what happens is with the help of metadata, just a second, with the help of metadata, you are basically not allowing systems to get that access. Okay, so for example, there is a table for you. Okay, you have a big table over here which has multiple data sets in it. Okay, data in it, like row 1, row 2, row 3, and so on. Okay, could you just give me a second? I think somebody is at the door. Really sorry, huh? I have to like just give me a second, huh? Sorry. Yeah, sorry. Okay, actually nobody was there to attend them. Okay, so where were we? So we were doing IAM, right? So you have like rows over here. You have your name, address, phone number, pin code, product that you have bought. Okay, product is okay. We know which product it is. Quantity is also okay. We can know this for analysis. Uh, Attaching it to your name, address, phone number, pin code is not right. Suppose that there is a POS machine where you go and basically when you buy things, you get a bill generated over here. Okay, there they can tell you that, sir, this is your membership, these are the points with it, and all that, right? It is okay because you are at a customer interface role. There you need to know such information. A person who is doing data analytics or some level of analytics, they don't need to require that. They need to know your name, at least your phone number. Okay, address may be required, but address is also not right because that's a personal identifiable information. We call it PII. Okay, and then there are SPIIs, which are basically like your Aadhaar card, your PAN number. Nobody needs to know that. That's not required. Okay, the maximum they can know from this pin code, people are buying such product. Okay, so we don't want our data analytics team or certain team or marketing team basically to know this data. So with the help, whenever a marketing person would ask for an access to this particular table, with the help of an IAM policy, which can be basically set through a JSON file, you will say that if the data role, if the accessing role is basically marketing, please don't give these three columns to them because those are PII information. We don't want to share our customer information with the marketing team because this is internal to us. Maybe it is a GDPR requirement, okay, or it is an Indian law requirement that we don't want to give this data to anyone. This is only for mailing them their products. Nobody knows who is buying, okay. So this is how IAM policy works, okay. And then IAM policy can have some level of granularity where you can basically stop access to a field also. Like if you don't want for row 1 that a person can know what was the quantity, you can basically block it. But that level of blocking is not required. A general level of IAM policy is always added to every bucket or every storage, or to an every table, and that is more than enough. Okay, and this all these things works through metadata. Okay. Okay. I don't know why this is okay. Now moving ahead, uh, then comes your Redshift. Redshift is basically based on your PostgreSQL. Postgre is your, that database with an elephant as their symbol. That's Postgre. Postgre is basically your one of the most scalable, and performance wise, I'm not sure because I have seen a lot of issues with that. But yes, if you want to go for storage and good level of BI processing, it's good and it's scalable. Okay. So Postgre is one of your, if you search on the databases for warehouse, Postgre will come at number one. However, there are things. Okay. So Amazon Redshift is fully managed, petabyte scale, data warehouse service in the cloud. When you say petabyte, then why do you need a lake house? We'll come to that. Okay. It is serverless. Okay, serverless you study on your own. Huh? It is a very simple thing. You will know. I have told you how VMs are made. I've told you uh, how virtualization is done. Serverless, I think you should learn, try to read it on your own. Okay. And analyze the data without usual configuration of provisioned. This also you should learn. Okay. What is provisioning? I'll tell you, I can tell you right now as well, but I want you to read, because if you don't read, you will not come uh, at this level. Okay. And this is Postgre. Basically, if you serverless and provisioning is something everyone should know. Okay. Those are your basic cloud concepts. Okay. Let's clear it. Put it here somewhere. Okay. Okay. So architecture wise, how it goes, it has a leader node that manages your query planning and coordination. What do you mean by query planning? You send a query to a system. I'll explain this diagram in a second. Huh? Let me just finish this side. I'll come to this diagram. So what happens in query planning is basically uh, whenever you send a query to your system, it has to be planned. You can't run and execute a query if you have like, if your system is scaled to like 100 servers, you can't send the same query to 100 servers, right? So you need to know, like for query one, I have to talk to server 5, 6, 7. For query 2, 7, 8, 9, something like that. Okay. So that's what it is called, query planning. And query to be planned in such a way it is efficiently executed. Like you have multiple things in your query, like where and then there are level of filtering. You need to know like which filter comes first, how which filtering can be done efficiently. This is called query planning. Then coordination means like what I've told you, right? Server 1, server 2, server 3, I'll send because the data resides over there, and that's all. Compute node stores your data basically, and they do the massive parallel processing. MPP, the most favorite interview question. You have a distributed system. This is called a distributed system. Okay. You have a coordination system in the front. You have a UI. From the UI, you are talking to the system. It is connected to everything over here. Okay. This is called a distributed system. You have server 1, server 2, server 3, server 4, and 5. Let's say. Okay. So a single processing can be done over here. But if you have 5, you can get close to 4.5 or 5x of performance. Okay. So that is what is called massive parallel processing. Tomorrow, if you want to run a processing query, so you can send it to 5 servers, saturate them, and get your answer. Nothing more than that. Columnar storage, I have already told you, reduces IO, improves compression. I have told you, so better compression. IO reduction means you have your SSD. You have your sectors in your SSD. Okay, each batch maybe of 16 KB or something. So if you have like 1000 IOs or something, so you are writing 1000 sectors in it, okay, of 16 KB size. Okay, so if you the more that you write, the higher is your bill, higher is your hardware use, lower goes the life. So you have to reduce the number of IOs. Okay, so the SSD after 5 to 8 years, it becomes maybe down 10 years, and after that it reaches a service life cycle and you have to remove everything in it. So you have to save your hardware if you want to make money as a cloud provider, right? So you have to reduce your IOs as well. Okay. Then there are scaling techniques. You have elastic resizing. That means in the same node you can basically scale everything. You can scale, I'm not sure if basically you can basically increase the hardware requirement or something like that, or maybe prioritize your this part. I have not used elastic resizing, but yes, concurrency we use. Concurrency, what happens is you whenever like you are running a Netflix show. Okay, behind that there is a Netflix servers which is running, which is tracking all your metadata and all that. If today if there is a new show which is going to be really popular, okay, so you add more transient clusters. Transient clusters are those clusters. If you have a 100 node cluster right now and you know that this can't take the amount of load that is coming in, so you add one more transient cluster over here with 10 nodes or 20 nodes, and this will basically get you all the processing power that is required to process your data. RA3 is their virtual machine type. Okay, that is why they call it RA3. That decouples your compute and manage. Now what happens is they are trying to do what a data lake house will do. They are basically do decoupling everything right now. Okay, and RA3 is there one of the new ways of scaling, and if required, use it. Otherwise, concurrency makes 90% of your things work. Okay. Now coming to this architecture. So serverless, you will study. Serverless is basically you don't need to manage anything. Okay, that's for the start. You have your leader node, your compute nodes over here, your cluster is there. Basically, a combination of your leader nodes and your cluster node and your compute nodes makes a cluster. Okay, this is what is called as a cluster. And so this is Redshift managed storage. You can basically you should go for a managed storage because this takes we are not an expert and are not interfacing with the cloud directly. So go with the managed storage. Then you can have your S3 storage. I think you use Spectrum over here to basically read your data. So operational databases are some live query databases, incremental queries, and then you have SageMaker basically that is used for your machine learning work. Okay, JDBC, ODBC is for your legacy system. When you were supposed to use your legacy system, back in those days, you used to have a JDBC or a ODBC plugin. Data API means you use a data API in between two systems to read the data, and then you have storage, acceleration, and compute. Here I have put a simple diagram of data sources. Your operational DB is streaming data. You are sending this data to Redshift. You have a leader node, you have compute node, and then you have a BI tool. Because this is quite colorful and sometimes people confuse, so we have kept this diagram. Okay, the source of all this is AWS Redshift documentation. You can have a look at that. Okay, and next slide. Just a second. Yep. Okay, so query optimization you can do through distribution and sort keys for minimum data shuffling. Basically, you put your keys in certain manner and distribute it in a such certain way that whatever data that is hot for you, hot data means basically the data that you want to read frequently, like like for a 24 hours of data that you have collected, it becomes a hot data. Warm data is something like when you like there is a terminology called data tiering. Okay, data tiering means this is important. Okay, these days they ask a lot. Data tiering, so you have hot, warm, cold, and then there is glacier. Okay, Hot means any data that goes up to 2 days. You can basically you put it on a very fast storage so that you can retrieve it quickly. Warm storages, maybe you have a data for after 2 days. So whatever data remains for the next 5 days, you put it on warm. And cold storages, maybe after whatever, leaving the 7 days, and maybe let's say next 20, the last 23 data goes on cold. And this goes for like year. Basically for 1 year you want to keep your data. So hot data is quite fast. You can read it as much as you want, you can update it. Sorry, warm data doesn't get updated, it only gets read. Cold data only gets read. Okay. Glacier data is like an archival system. You can get it whenever you're trying to archive, basically read an archival data, anything beyond 1 month now, your cost becomes very high. Okay. Such things are only retrieved when you have a anomaly. Maybe you had an anomaly like this for 1 year back. Then you go and read this glacier data. Otherwise, it is 3 times the cost of retrieving compared to a hot data. Okay. So that's the thing. Then comes your materialized view, result caching. Caching, I've already told you, right? So materialized view, I think this is pre-processing everything before sending it. We don't use that much. We do a caching. Okay, you just materialize. Basically, I think you can do pre-processing, store, and create a view, a separate view where you have all your processing already done. Whenever you do a refresh, your data will be pre-processed at the back and it shows. Result caching means you can keep your latest results cached for 24 hours, 48 hours, depending upon your memory limit. Workload management means you prioritize things which can be easily done or which requires priority for now. Cost optimization, you can pause and resume your cluster. When you have deployed a cluster on prem, you can't do this, pausing and resuming. But on cloud you can, and you only pay for the time that you have consumed that cluster. Reserved instance for predictable workload. Okay, sometimes you reserve some instances, which means that you have already reserved like 10 compute node and maybe 3 worker leader node cluster already with you. Whenever your current cluster starts breaking because of workload, you shift it over. Some workload shifts on this reserved cluster. RA3 managed storage, pay for compute separate from storage. This is a different thing, but yes, you can use it. Spectrum is basically you don't store your data on Redshift, you store it on an S3 storage, which is cheap, and whenever you need your data, you read it in the Redshift. Okay, that's it. Okay, I may take 10 more minutes. So, okay, AWS Redshift basics. What type of workload it's good for? It's good for reporting, BI dashboarding, large scale analytics. How Redshift differs from your relational DB? Uh, RDS, basically your relational database service, is OLTP. I told you, right? This is used for bank or basically adding some some asset compliance you need. Redshift is only for analytics. It is read-only workload, something like that. Okay. Can Redshift query outside its cluster? Yes, I told you right over here. You store it on S3, you can basically query it. Features and advantages. What is zero copy cloning in Redshift? Creates a new Redshift cluster instantly without duplicating the data, useful for testing. These are good for machine learning teams and data science team. You basically don't disturb the current data that is sitting in Redshift, only create a cluster, pull the data in memory, do whatever you want to do, and basically remove that cluster. How does Redshift handle sudden workload spikes? You have already told you. Concurrency scaling, add temporary clusters. What role does the leader node plays in Redshift? Coordinates, query parsing, planning. Execution happens on compute node. So basically our leader node, which is here, okay, its work is only to do the planning job. That's what it is saying. Okay, I'll just clear everything now. Clear my drawings. Okay, architecture, query, and cost optimization. These are some questions for you. How can we optimize query performance in Redshift? Use distributed keys, sorting, and materialized view, results caching, and workload management. What are cost optimization options in Redshift? Pause and resume your cluster, reserve instances, RA3 nodes, Spectrum for S3 queries. How does Redshift ensure security? I told you, right? Key management system. Okay, so you have a 64, I think, bit key over there, and VPC isolation. You put it your Redshift behind a virtual private cloud, and IAM roles. I've told you, you have your policies to access encryption. Okay, can Redshift be used for ML? Yes, via and is integrated by SageMaker. And how does Redshift compares to Lakehouse? So Redshift is warehouse first structure. Lakehouse is data warehouse plus data lake plus AI plus ML. How does Redshift fit into modern data platform? Act as a central analytics engine integrated with S3 Glue, ML services, and BI tools. Okay. Now the favorite topic. Preeti, we have some time.
Yes.
Okay, I'll continue with this. Okay. So, if everyone is there online, uh, I'm not able to see the chat. Okay. So, all are fine with it. And because I'll start Lakehouse now. So, at least give me a thumbs up if you are okay with it. Okay. Okay. Okay, let's go. Okay, Lakehouse. So, we have spoken a lot about warehouses, right? So why Lakehouse now? This guy, basically, it is the name in every strategy room that is going on to for teams who are now looking into moving to a modern data platform. Okay, every team, everywhere, you will be asked Lakehouse. But I'll tell you something: if you have like a 10 years of plus experience, then only go for a Lakehouse right now. Because what will happen is, even if you are a fresher right now, and then if you are in a startup, they might let you work on a Lakehouse. But if you are in a product company, service sector right now, they might not give you a chance right directly to work on a lake house, because there the company's complete area, all the data is coming, and you have a lot of strategy to look into, right? So today, when you are trying learning how a data warehouse works, so directly you can't be put on to use a lake house. Okay, it will be an ambitious and a very bold step, but it's good if you're getting a chance for it. Okay, so uh, why data lakehouse now? Why everyone is when they're happy with a petabyte scale system like Redshift, then why do you want to work on a lakehouse? The and the question remains: if you have seen my slide now, everything starts with what? Okay, if I show you now, if every question that I have put through is always about what? Okay, there is a reason for that. There is an analogy behind why I'm using a what instead of any other word. Okay, there are you know those strategy things that you learn. They tell you there are five W's, four W's. Okay, the most important that I find is what. What is this? What is that? Okay, if you are familiar with that, sorry, if you are familiar with what, you will get it why also. Okay, so what is the lake house? So it gives you a capability of your data of your data lakes and data warehouse. So what capability does data? We have understood the capability of a warehouse. It's an OLTP or OLAP system, which basically helps in processing a large amount of data. But what facility does data lake brings? So if you remember, I told you the data in data lake, you can put as much data as you want. It is quite cost effective. This thing, after a certain point, data warehouse, when you have a lot of data, it is not cost effective. But data lake is for storing data. But if you try to do a complex query or querying multiple queries on data lakehouse, it will fail, but it will not fail. So cost wise, on a large data set, this will fail. Query wise, this will fail. So if we combine both of them, they are complementary and they give you a lake house. Okay. But how do you build a lake house? That's the thing. It's easy to say than doing it. Okay. So you're basically everything is all about storage. You see over here, this is storage. S3, Azure Lake Storage, Google Cloud Storage. Sorry, this one was uncalled for. Okay, yeah. Okay. I can't move this without it. Okay. Just a second. Just give me a second. I told you about block storage, right? Block storage is a very cheap storage. Everything you put, it is put in a block. Let's expand this block. Every block is a serialized byte. Okay. So if you have a file now, it will be serialized and it will be sequential, which means anything, anything that you are storing on a block storage, it goes from point 1 till point 100. Let's say there is a file 1, I would say. If it is of 100 points, all the 100 points will be written sequentially. I'm not talking about bits, bytes, or zeros and ones. I'm just giving you a hypothetical example. So it will be written in a serial way. Next file after that, serial. Okay. This is a block storage. Okay. It is stored in such a level that it becomes efficient and cost effective, and the compression is good. Okay. But how does a block storage solves your problem of Lakehouse being quite fast on queries? Okay. Remember I told you metadata is the heart of any lakehouse. Okay. So we use metadata to access this block. Okay, this block. So there are hundreds of blocks which are coming, and then you might have heard about buckets, right? So everything gets stored in a bucket. Again, a jargon. Don't no need to worry about it. Just understand what is the block storage. On top of each block storage, or whatever you want to say it as a bucket, let's say this is a block storage, there sits a metadata. Okay. And simply this is called a Parquet format. So Parquet format is columnar. Okay. It has metadata. How does metadata help? Whenever a query will come, the query engine will look into the metadata. It will know, okay, I want to search Soha Joshi's name. Where is he sitting? So metadata will tell, okay, from point 1 till point 100, you will find all the information related to Mr. Soha Joshi. Immediately it will unpack and get that data, put it in memory for processing. That's how your lakehouse works. Okay. Governance, query engine, BIS is all time pass. Okay. You will get this facility everywhere. The most important thing that you need to understand is how okay, that is your heart of every system. Okay. On top of that, there is something called as open table format. Again, these are metadatas. Metadata, did I come out of the meeting?
Yes.
So can we connect it back?
Yes, yes, you are connected now.
Okay. So I think all the attendees' names are getting anonymous right now. So I don't know who has. Everyone is there. Yeah. I think it got reset. Sorry. I'm taking more time than I had thought about, but okay, everyone can view. Give me a heads up if you can.
Yes.
Okay. So I think there is something called as somebody had asked me, right? How can I'll see. I just read that. Okay. I'll come back to that question again. So Parquet is your game, and in Parquet Okay, so Parquet is your game. You need to understand what is Parquet. You need to understand what is block storage, and then you need to understand what is an open table format. Without these three things, if you don't know, understanding governance, understanding a query engine, Presto, Trino, Spark, Flink, Redshift doesn't matter. It doesn't matter because these everything over here is plug and play. You give one command to GPT, it will give you a complete setting to how to deploy. Now this is not your job. I think in next 4 years even nobody will consider asking you questions like how can I increase the Presto. There is something called as Pinot. Okay, then there is Druid, Apache Druid, and then there is there are other things also. Okay, so there are hundreds of tools in Apache library which are coming up. How many can you keep in mind, and how many can you basically work on? Okay, and I'll tell you a way of finding like which tool exactly you need to learn. You can't learn all the tools in the market. Okay, there is a way to know which tool you should go for. So I hope open table formats, basically those are a meta layer wrapped on your around your table files. Okay. Sorry, again that is on the call for. Yeah. So it is built on top of your parquets schemas. I'll tell you what is. Okay, if you have read this line now, I'll tell you what happens. You understood that Parquet told you like on which block, on which hardware level you need to search for your information. Okay, now there are hundreds and thousands of Parquet files sitting in your cloud storage. Okay, and basically if you have a table right now, you want to view your things in this way, right? You want to view your data in columns and rows. This is not going to help you with columns and rows. Like finding your data will not present your data into a row and column format. Okay, so again metadata layer comes into play. This metadata of open tables, OTF, okay, sits on top of the metadata layer of Parquet, and they generate your row and column view which you are seeing on your visualization tool. Okay, so there are two levels of metadata which is coming in. So next time if somebody asks you what is data lakehouse, I want you to know this first instead of knowing what is Trino, Presto, and all that. Okay, these are just distributed query engines sitting somewhere connected, plug and play. Scale it, you will get whatever you want. But this is the theory that you need to learn. You need to understand. Okay, I hope I'm making sense. Okay, heads up, because this is something important for me. If you're able to understand this, can you give me a heads up? Shall I repeat it, or I hope you have understood it? Okay, so just understood this simple thing: block storage, Parquet, and over Parquet, how open table is retrieving your data. There are hundreds and thousands of things which are getting developed on the open table format. You can't just work on everything. You should understand one thing: your data warehouse was asset compliant. Okay, the data lake was somewhere it is not. But with open table formats, you get that asset compliance, which means now you can basically store your transactional data without any problem. Without, when you are basically writing thousands of millions of data in your data warehouse or somewhere, you don't know which one has been written or which one has not been written, right? But with asset compliance, you can basically be free of any absurds like crude operations, insert, delete, update. All these operations are taken care, and you know that operation has been done and it has been done perfectly. Asset compliance, very much important. Schema evolution. What is schema evolution? If you have worked with SQL like now, you will know that first you design your schema for any SQL table, right? Tomorrow, if you want to add one more column to it, you will not get you have to basically rewrite that table with that new column. But schema evolution, it helps you adding that column on the fly. That is schema evolution. Time travel. Basically, you have versions, so you can basically travel back in time to know like which version has what data has been changed. That's I think time travel. Asset transaction, I've told you reliability. This brings reliability. Reliability was not there in data lake. We were just putting over the data. We were not using it cost. We knew that this is cost effective, but we were not making it reliable. Reliability come with ACID. Decouple storage and compute. Elastic scaling. Okay. Elastic scaling means now I've told you, right? In cloud, we were decoupling it. So decoupling will happen on the lakehouse architecture immediately from ground up. Okay, if you see that RA3, they have started to decouple it now, but with Lakehouse, it will be ground up. Okay, cost saving. Since you are now moving into a Lakehouse format, data lake format, you will have cost saving. Diverse workloads, BI, streaming, ML, AI, everything runs on the same thing. Sometimes you will know that one thing which is called single source of truth. Okay, which means you don't need to go here and there to know which data set you are looking for. Everything will be sitting on your lake house. Okay, query engine, you will have Spark, Trino, Presto, Flink. So these are some query engines. These are fast query engines. I'll come to it. Why do you need Spark, Trino, Flink, and everything? But just remember right now, these are just query engines. Okay, very powerful, but right now, just understand those are just query engines. They come under query engines. ML and AI integration, direct access for training and feature engineering. What used to happen is normally when you're doing an ML and AI workload, you will have your place where you run your Jupyter notebooks, right? Jupyter notebooks will connect to your some level of data warehouse, which is basically serving your Jupyter notebooks. Now you don't need to go to a data warehouse. You will have a lake house setup which can do it. Okay, governance and catalog, basically governance means your access control, your security and all that. Catalog means like where your data is sitting. Lineage is important. You know, when your data great Colibra. Okay, there is a tool called Colibra. You know, I have a system sitting in USA. I have a system sitting in UAE, or let's say one is sitting in Australia. Okay, all these are weather IoT devices, and I want to know that where the data is coming from. Okay, it came from Australia, it came from USA, it came from UAE. It got processed, it got stored, processed, got stored, it got visualized. Okay, there are 100 layers in between that I'm showing this. Okay, tomorrow you found that your one of your instrument or one of your visualization is not working fine. Suppose that this is your data should have been like, your data is coming in this way, you wanted a smooth something like this. Now you want to trace back to which of the sensors in which country is malfunctioning. Can you do that? It will be a nightmare for you to know which sensor has malfunctioned. Hundred and thousands of sensors are working over here. Okay, a data lineage can tell you like this data came from this data set came from sorry this data came from this data set. It is stored here, it was processed here, it is coming from this location. Data lineage, very important. And then security. Okay, cost effective, cheap, this all you will get on internet to read. Nothing special in this. Okay, and there are three open data platforms: Delta Lake, Apache Iceberg, and your Hoodie. I'll clear everything. Okay, keep it clean. So I have not used Delta Lake, but these are basically Databricks open platforms, open data, open tables. Apache Iceberg and Hoodie, there is a difference between them. Okay, Apache Iceberg is basically it's not for very fast read and write. Okay, you can put a lot of historical data in Iceberg. Okay, but what happens is when if you are building your data lake house on S3, it direct in S3 tables, it supports your lakehouse, sorry, Apache Iceberg tables, okay, right out of the box. So there you will not be able to get Hoodie support that you are thinking of getting from your system, okay. And now what? How Hoodie helps you? Hoodie helps you in getting a very fast ingest. When you add Flink is basically your data integration. You remember our first slide? I'll just go back to our first slide. Okay, I'm doing it a bit fast. This data integration thing, this is Flink for streaming data. A lot of data will come through quite fast, quite fast. Okay, and there you need this Apache Hudi to do those crude operations, writing, inserting, deleting, quite fast. And it, in comparison to Iceberg, it is very fast. Okay, so you put your Hudi first, get your data from Flink, from your sensors, and then write that data into Iceberg tables for your archival or any level of static analytics. Static analytics means where you are basically your data set is not getting updated and you are sitting over there to work on it. Okay. Moving on. Yeah. Okay. Now, because I like Apache Hudi, so this is a small architecture that they have done. Lakehouse, file format, table format, catalog, compute engine, storage engine, your analytics, everything we have discussed. Okay. So Lakehouse is basically this elephant is HDFS. These are some buckets. I think this is for Google Cloud. This is for, I don't know, maybe Azure, your type of format, JSON, Avro, Parquet. Okay. These are the ways in which you are storing. Then on top of that, you have Iceberg, you have your Hoodie setting, table formats, Delta links. Okay, so just remember this. This is block storage. Okay, which we have just discussed about. This is your Parquet format sitting over block storage to tell you where your particular data is sitting, and this is your table format, which is building your tables on top. Okay, so these are three levels. And then you have a storage engine, which is basically sending the storage to the right place. You have a compute engine like Spark, which is basically doing your ELT and all that. Okay, and doing your processing. Flink is for streaming stuff. Spark is basically for streaming and batch analytics. Then you have your Power BI, your Jupyter, Tableau, Click. Superset is open source. You can work a lot on this. Okay, so we'll just go through this side. Lakehouse storage. Data stored in large lakehouse stores large scale object stores. Object I have already told you, with efficient format like Parquet, format engines, Parquet and OC. Basically, ORC is one more format, but I have not used it much, but it is good. It's again a columnar format. Okay, columnar I have already told you, right? Everything which comes under one column. OTF, open table formats like Iceberg and metadata. For metadata, I told you everything is all about metadata. Compatible compute engines are these. Scalable expert decoupled storage and compute. Okay, so decoupled means you can increase your storage as much as you want. You can increase your compute as much as you want. People who have worked on HDFS, they would have stuck with this problem of increasing the compute while keeping the storage same, or uh, or basically decreasing the compute. Like you can't play with hardware on HDFS. Whatever happens, it happens in a single system. Okay. Are you getting any noise in between? Okay. And then you have your basically compute engines as Trino. I'll come back to Trino and everything. Okay, let's just discuss this. Then on a separate area, I'll tell you what is a Trino, what exactly it does. Okay, and machine learning use cases by exposing data, feature engineering, and all that. Data governance and catalog governance, I told you, right? Security and all that. Okay, access control, catalog integration, enables open interoperability. Okay, now comes the word interoperability. Okay, interoperability means on the same storage, on the same thing, you can run Hoodie as well. On the same storage, you can run Iceberg as well. And on the same thing, you can run your Parquet format as well. Okay. Uh, Hoodie, Iceberg, and you can have Delta Lake. Same storage. Maybe if you have a table sitting over here, you don't need to do anything in this. Okay. Same type of storage, your block storage will remain the same. but any kind of an open table format can come and read it without having any issues in it. Okay. Okay, this might have cleared a bit about what is a lakehouse architecture. I want you to read this paper as your homework, as whenever you get time. A lakehouse, a generation for open platform that unifies data warehousing and analytics. Okay, this is the first one of the first papers on lakehouse. Basically, the idea of the lakehouse came from this paper. It is given by Databricks. Okay, you read it, you will get everything. You don't need to go to a person like me to understand this. You read this paper and you will get everything in it. Okay, and whenever you have an interview, read this and go over there and show that you know everything. Okay, I'm pretty sure 90% of the interviews who take interviews, I'm not criticizing anything, but they research papers are very less. People who are reading research paper and taking interviews, uh, they know what they're talking about. Okay, and still not being critical, but I have seen like some of my juniors, they have gone for interviews and they have been asked to to know a particular Python library. Okay, library is fine, but if you want to know a setting inside a library, that becomes a problem. Nobody can learn a full library. You have your access for the internet. You can go and optimize, use an LLM these days to basically make it more optimized. But research paper, this is where you need to focus. You can't leave it. Okay, the last thing. So I'm open for questions. I think for today, this is one thing is Trino and Presto. These are your compute engines. So what happens in something called as in memory. So before I open question answers, I'll tell you something called as in memory databases. Okay. Previously, there were data stored in your hard drives, okay, or your SSDs. Nowadays, and processing used to happen over there with CPU and memory. Nowadays, your RAM goes up to terabytes. Okay, and you basically read your hard drive or SSD once, single time, and bring all your data into RAM. Now this becomes quite powerful and it processes over here. Okay, so these are basically in-memory databases. That's why they call in-memory, because they're running on RAM rather than on hard drives and or SSDs. Okay, Presto, Trino, because what happens is till this point you don't have any query engine. Okay, query engine basically will go to that table, will go to that particular Parquet file, and basically look for that data inside your bucket. But you need a query engine in front which can understand your SQL query. Your open table formats will not understand the SQL query. You need a query engine which understands an open table format, which understands your SQL query and can give you a result that you require. So that is why we need a query engine right now. Okay, and there are in the market there are subs. Okay, you can know that it is a sub-second query engine. Okay, there are query engine like Druid. Druid can give you a query in a minute time. Pinot can give you it in a millisecond time. It depends what is your requirement, and based on that requirement, you select your query engines. I think that's all for me now. One more
Thank
thing. Yeah, just a second. Sorry, Apriti. Just a second. One more thing. You have, if you really want to know now which tool you want to learn, because that might come up. Gartner, Forrester. These are two companies which do your regular analysis with PwC and all other companies as well. They do which is called as a magic quadrant kind of a thing. Okay. For every type of use case, there is a magic quadrant. There are certain tools which come over here. Okay. So you need to pick any three of them or two of them, and that should be your industry standard. That's all. Okay. I'll stop sharing now. Okay. Let's start with the Q&A. I think
Okay,
then we
before that, actually, we have one session feedback form which I'm launching from here, and I would like to request everyone, guys, please. It will not take more than 10 or 20 seconds. Please fill it out, and side by side, we'll take questions also. Okay. So first question is, okay, which tool we can use for Lakehouse like Python?
Okay, so you want to do some kind of a processing?
Uh, It's not written here. It's just like which tool we can use for Lakehouse.
See, if you want to build a lake house for storage, I'll tell you there is something called as MinIO. Okay, MinIO is like on your on premises or on your laptop, you can download MinIO as a Docker file, and it will give you S3 capabilities. Okay, block storage capability. Over MinIO, you can use an iceberg. Okay, iceberg tables, and on the iceberg, basically over that you can have. I would say keep Trino. Okay, use Trino first. It is user friendly. Either Trino or okay. For Trino is a query engine. Basically, it doesn't. It basically queries your data inside it. If you want to write on the S3 table, use either Spark or Flink. Okay, these are your basic setups for now. Mostly Spark and Flink is used everywhere. You have NiFi also, but NiFi is plug and play, and sometimes it has some issue with the scalability. It's just a data mover, light level of processing. If you need heavy processing, go for Spark or Flink. Okay. So if you want to try a setup of a lake house on your own system, use MinIO and just give it like 10-20 GB of your space. Over that, you can have either Iceberg or Hoodie. Over that, you can have a Trino for your just try some SQL queries with it. You want to write some data, go to Kaggle. On Kaggle, basically, you can download a data set of maybe 10 MB or something. Write that data set using Flink or Spark or any data ingestion tool or your MinIO. Your basic operation is there, and then you can basically do some level of processing. Yeah.
Okay, can we like move to another question? Sharat, can I move to another
Yeah, yeah.
question?
Please go ahead,
Okay,
please go ahead.
okay. Sir, how the cloud providers will charge? It is based on records, fetched count, or the amount of data we store into cloud database.
They used to charge based on cloud, I think data you store on cloud storage. But now what happens is you can store as much data as you want on BigQuery. But if you try to query it or you try to move that data somewhere else, then they will charge you. Okay, charging model will depend upon how you are. Basically, they change it time to time depending upon their requirement. But sometimes it is memory RAM based. Sometimes it is your how would I say your storage base. Sometimes it is in ingress or egress. So ingress basically what happens is if this is your cloud system, you have your network over here. Whatever data you are writing, it is called ingress. Whatever data that comes out, it is called egress. So they charge on your egress cost. Whatever you are writing on your big query, it doesn't matter. They can keep it there for some time. But if you are trying to read it from external system, move that data across zones or regions, then they will charge you. And if you want to know how they are charging, their every cloud provider provides their calculator. Okay, so whatever service you want to use, for example, you want to use S3 or you want to do Redshift, you can just open their calculator and see how they are charging for per GB and per region wise. Okay.
Okay, okay, thank you. Another question is how to check the data errors at source level.
Data at the source level, you need to have some scripts over there. See, there is something called as data quality. Okay, it is there is a tool called grade expectations, but grade expectation works when your data is inside. Okay, I'm not sure on the fly if it is going to check it, but suppose that you have a log file over here. Okay, and you have a tool like Flink in between. Okay, so Flink basically it runs on Python. So you can write a Python code to basically check if the data is present or not. If there is some error format in the data, you can basically use Flink to on the fly check all these check, and then you move it to your Kafka maybe before sending it across. Kafka also has Kafka streams. You can use Kafka streams to process your data and check and do all these checks. There is one more thing which is called as data contract. Okay. Data contract is again a way to check your data if it is basically it has certain things being provided by the data. Okay. But on the source, if you want to do it, you do it through scripts. Okay, using if and else statement. Okay, and if you are facing a lot of issues, like there are people who faces a lot of issues in your data, then you need to talk to the host which is generating the data to modify their script, because every time you do a check over here, you are using a lot of processing power. You can only see there are issues which are known. Okay, those are to be basically sent back to your team to rectify. Then there are something called as outliers, which are which may come once in a while, that you need to do. If you are doing an unstructured data, you use regex format to basically regex or grokking you do to to process it. Grokking means basically, if this is starting with a character, you make a grok pattern to recognize this, that anything that follows till the next space, you will have it's going to be a string. You put it in this field. Okay. But if you are facing a lot of issues on a structured data like logs or something, you need to go back to your team to rectify it.
Okay,
Yeah.
another question. How do we practice data warehouse for learning purpose?
Data warehouse for learning purpose. Download Postgre. I think Postgre will help you out. There is called as Postgre. You can download, basically use your Docker file again. You download Docker on your system and try PostgreSQL to basically data warehousing things. And what other data warehouse we use? If you want to use a NoSQL database, which is basically your document database, you can try Elasticsearch as well. You should learn Elasticsearch. It is being asked everywhere. It has a Kibana visualization also, because I use extensively Elasticsearch for such requirements. Kibana can help you basically graph many things. So it will be an add-on on your CV. Like we look a lot for people who are having Elasticsearch experience, but okay, it is coming up as a technology. You should know that, and it is also very popular with vector DBs. So vector DBs are basically used for your large language modeling. Okay.
Okay, another question. Can you suggest some popular tool for ETL and ELT and a data lake and warehouse also?
Data lake. Good question. Let me just check. I have not used data lake for a very long time. I also like, the best way to learn something is to use your credit card, not by paying. Okay, I'll tell you something. You get three. I'll tell you something. Okay, you want to use cloud. Okay, Google on your credit card provides $300 of worth of credit for 90 days. Okay, I think Amazon provides around $200 of your credit for around 6 months, and then Azure also provides some credit. At least for one credit card, you can have three cloud providers. You can just take a VM over there. Okay, in their marketplace, you will get all your tools like basically your data lake house, data warehouse, and everything, and you can basically use them. Okay, much easy to config, and you will get a real VM over there to use. You use for 1 hour every day, and you will not be able to burn 300 credits in one cloud provider. Okay, now coming to the tools. Okay, so I think data lake, you can basically I think data lake you can build on this minio. Directly building data lake will not, I'm not sure if there is a tool in my mind right now which can help you in that. Okay, basically you can use Hadoop HDFS. Yeah, Hadoop can be used. Hadoop, we're not using Hadoop, so it doesn't come in my mind immediately. You can set up an HDFS storage. Inside, you store all your data. processing tool which you need to learn is Spark. Don't avoid Spark. It is used everywhere, be it ML, be it your traditional ML, be it your LLM. LLM uses PyTorch, but if you want to scale your PyTorch work, then you use Spark again. Okay, so if you are doing ML, you are doing your LLM things, or maybe your neural networks and all that. Spark is good for working. Spark, you can have your data frames over there, and you can do any level of processing you want. Go with Spark as your processing tool, or Flink. Okay, for real-time database, only for real-time I'm saying Flink. For everything else, you use Spark. For your storage, you can use an HDFS. You can get everything on your Docker image, and you can load it over here and work around it. Okay, if you start using Docker now, you will understand what I'm saying. You will get any more 99% of your free tools will be there. Okay, open source, and open source is the way ahead right now, because as the data scales, your costing will be burned. And if you see that most of your tools which are there on the cloud are basically a layer on top of an open source Apache project. Okay, next.
Okay. What is observes and control in ingestion?
Can you come back again? Can I read
What
this?
is what is observes and control in ingestions?
I am not sure of that. Sorry, I have to look into that. Observes and control ingestion. Let's see.
No worries. We can move to another
Okay.
question.
Got it. So basically, it's a very, I think, observe and control managing in, but that is for food. I think you are saying observation, right? Observability, if you're talking about, observability is nothing. Like, it's a very simple concept. What happens is, whenever you are writing a data in a warehouse, you are generating some logs. Your tool will generate some logs. Okay, those are basically some level of metric, like how much data is getting ingested, how much data is getting processed. And you basically use a visualize, you store this data in a warehouse, and you visualize on that data set. If you use Elasticsearch, it is specifically is being used for this use case, observability. It is called APM monitoring is also there, application performance monitoring we do, and it is called an APM monitoring, and Elastic is quite good in that. Okay.
Okay. Okay. Thank you. We are done with the questions actually. One
I think
last.
Rajiv has
Bef-
asked something, right?
Sorry.
Rajiv Kumar, I can see now.
Yeah. Okay.
If you
So
have 13 years of experience, system engineer, I have no job. Okay. So no job से job पे जाने के लिए क्या कर सकते हैं? See, first of all, you need to take your time to understand, okay, where you want to go. Coming in any field, if you are require like you are supporting your family and you are taking your time, like you don't have any other option, you have to work really really hard. I would not say that you have to, like, for next 3 to 4 months you should not be there in any of your family gathering anywhere else. Okay, I'm not kidding, because I've gone through these situations with many people. Okay, if you are picking up a new topic in your life, you have to give time to it. Like, I have a 3 days of holidays. I had like my two MTech classes in the morning for 6 hours, and then I am teaching you this. Okay, so 8 hours already gone. So you have to give time, first of all. Now, what to do regarding this? You go to Udemy, start understanding your courses over there. First of all, you need to have your data warehouse concepts to be in place. You need to know Spark. You need to know Flink. Okay, these are some data engines that you need to know. You need to understand what is a data lake, and then you need to pick up one tool. Okay, you need to pick up one tool from the cloud. because cloud jobs you can get immediately, and you have to clear the data engineering. Uh, in the previous, okay, I'll tell you regarding this. Okay, data engineering, you can basically get your certificate from Azure. If you're, I think if you're not employed right now, they will give you like 50% of, what do you call it, rebate on that. Get that money. I think you can save it from somewhere. Get yourself certified, start giving interviews, use ChatGPT to basically get yourself trained for the interviews. Basically their voice model is quite good for training you. Whenever you give an interview, always use draw.ai. I'll tell you draw.io. You build your own use case over there with all the blocks, okay, like a solutions architect. Whenever somebody asks you what project you have worked on, explain by sharing your screen. 90% of the people, they don't share their screen. You know why? Because behind there is a GPT running. And how they are caught, I'll tell you. First I'll talk to them in English, then immediately if I change to Hindi na, their system will not answer, because whenever your language is changed in the same conversation, your GPT will not recognize it immediately. It will get confused. So don't do that. Share your screen. Be honest. He will get your job. It takes time, and do not need to be disheartened. It might take up to 3 to 6 months. Okay. And ऊपर वाले का हाथ भी चाहिए होता है. It's not like that things work immediately. Okay, you have to like put yourself in that position. Until unless you work hard, you will not get it, because there are so many people. And this is for core engineers who have changed their jobs from core engineering. I used to work as a core engineer. I still have that experience with me. Don't shift to IT until and unless you really have a love for this job. Okay, go for core engineering, go for manufacturing. Try to start your own business. There are things like 3D printing going like wild these days. Try to do that. Okay, you understand something. See, already we have so many people coming out of college. Those who can sit 24 hours for studying. We are sitting at an age of 32, 35. Okay, at the age of 24, 25, I could work 24 hours without breaking a sweat. I worked 24 hours. I got in at 8 o'clock, came out at 8 o'clock. Doesn't matter for me at that age. At 30, I can't. 35, I can't, until unless I maintain a very balanced life. Okay, so now our country is changing, money is coming up, you can have a diverse source of income, I would say, before you want to get into a job, because what happens is, if you are focusing in one direction, if it is not working for you, you will get frustrated. You will really get frustrated. And if you have a diverse source of income, and you don't need to feel bad if you are, basically, I've seen people who are working, driving a car in the evening. Try something. If you need that money to get these exams done, you have to push yourself. There is no, I can't give you a tablet to get your job changed or something like that. Okay. And coming from telecom field, switching into IT. Okay. IT is already getting saturated. Where will you go? And LLMs are already automating your work. Okay. But if you need an advice from me, go for generative AI. Okay. Generative AI is working. For that, generative AI, there are some books with orally. You need to read those books, and you need to get that level. But if you're working from core, I would say diversify your income rather than switching to IT, because you will be in the same race that everyone is there in this country. Okay. So okay, that's all from my end. If you have any other questions.
Yeah, one we have like structure is not only RDBM is correct.
Structured is not only RDBMS. You can say that it is RDBMS, but relational database management systems are different. Okay. Relational database systems is different. Structure means basically you follow some kind of a tabular format. Okay, RDBMS database means this table is connected to this table. Behind every RDBMS database, there is a structured format they are using. But the whole and soul of RDBMS is to basically connect multiple tables. Okay. So it is, yeah, definitely RDBMS. Structured data doesn't mean completely RDBMS, but RDBMS is just type of a database management system. It runs on a structured data set. Okay, and the structured data set can be in data lakes also. It doesn't matter if it is RDBMS. And yeah, sorry for being harsh, but I'm giving it true reality because I'm sitting in the interview panels and I know how things work. Okay, we don't want to say no to everyone, but sometimes there is a better candidate who is sitting there. Fortunately, unfortunately, he will appear on the interview. So how are you going to project yourself in that particular time? It all depends upon you, because there are people, like there are I'll tell you, in India we are not doing something which is called internships. There are people in US who are doing multiple internships. You know why internships? Because they want to show they have the experience in multiple domains. And one more thing I want to tell you, your interpersonal skills, how you speak in that interview, matters. I might not be knowing more than what I have told you today in Lake House, but tomorrow, if I have an interview for Lake House, I think I can crack it somewhere, because the interpersonal skills matters. So having a knowledge is only 30% of your work. 70% is how you project yourself in an interview. Okay. So build strategies for 70%. 30% comes with time and experience. So 70% should be really strong. This is up to you. You can basically build yourself in 6 months. This will take time. I'm 100% sure that comes with experience. But 70% is what we are looking for in every interview. Okay. Answering one question right is fine. But this is what is required. Okay. That's all.
Oh, okay, Saurabh.
All the
So
questions are done,
like
right?
before like ending this session, like any piece of advice you would like to share with the people?
Yeah, if you want to excel in these areas where the research is happening, read these research papers a lot. Okay, it doesn't matter how many Udemy courses you have gone through, how many certificates you have. It doesn't matter that how many X you have added in your Google certifications. It doesn't matter, Amazon, something like that. If you read a research paper, you are always ahead of the game. You have to read it, and these research papers are technical. They range from 13 pages to up to 30, 40 pages. Then they have their references also. But if you go through them, you will be like on the top 1% of the people. Okay.
Okay, thank you so much, Saurabh. Thank you so much for
Thank you.
delivering such a clear and engaging session. We truly appreciate you taking time to share your knowledge with us, and thank you to everyone who have joined us today. We hope
Yeah.
we hope like you found this useful and informative. If you like to revisit or share it with others, the recordings are also available. So until then, take care, stay curious, and keep learning. See you all next time. And once again, happy Janmashtami to all. And thank you so much once again, Shauraj.
Thank you.
Thank you. Bye bye. Take care.
Okay. Thank you.